Good day, everyone. My name is Mohamad Zariff, and today me and my group mate will be presenting our poster titled Comparisons of Methods for Isolating and Characterizing Antibiotic-Resistant E. coli and Salmonella from Dairy Cattle Feces. In this study, we aim to develop a simple and low-cost approach for detecting antibiotic-resistant E. coli and Salmonella in dairy cattle feces. Our workflow combines basic culture methods with molecular testing, allowing us to keep the process both accurate and affordable, especially for laboratories with limited resources. From our results, most of the normal E. coli isolates were still sensitive to commonly used antibiotics. However, isolates that grew on antibiotic-supplemented media showed much higher resistance, particularly to third-generation cephalosporins and quinolones. Salmonella was detected only rarely, and almost all isolates were susceptible with just one strain showing resistance. Overall, the strong agreement between the culture findings and the molecular test indicates that this protocol is reliable, cost-effective, and well-suited for routine AMR surveillance. To begin, here's a brief background. Antimicrobial resistance in bacteria from food animals is a growing global concern. While advanced countries often rely on tools like whole genome sequencing to monitor it, many developing regions do not have access to these technologies. This creates a need for simple and affordable ways to detect resistant bacteria, especially E. coli and Salmonella. Our study is based on the idea that basic methods such as disk diffusion and selective culturing can still provide reliable insights into antibiotic resistance and produce results that closely match advanced approaches. With this in mind, our aim was to develop and field test a low-cost protocol to isolate E. coli and Salmonella, evaluate their resistance to third-generation cephalosporins and quinolones, and confirm the results using PCR and whole genome sequencing. The researchers used three main methods. First, the disk diffusion test was used to measure antibiotic susceptibility, such as using a ceftriaxone disk to detect third-generation cephalosporin resistance. Second, they used selective culture on antibiotic-supplemented media like MEC with cefotaxime or ciprofloxacin and XLD or BGS with the same antibiotics. These media help isolate resistant strains that might be missed on standard plates, making it easier to detect cephalosporin and quinolone-resistant bacteria. Lastly, they use PCR, including both conventional and real-time PCR, to confirm the identity of E. coli and Salmonella using genes like WAC-A and TTRC. They also screen for resistant genes such as BLAST-CTXM and BLAST-MY2 to understand the genetic basis behind the resistance seen in their phenotypic tests.
For a result, first one is isolated bacteria. E. coli was observed in every sample. Lower levels were of resistant E. coli, 3-GCR and quinolone resistant. The Salmonella was detected in certain samples, but highly uncommon was resistant Salmonella. Second, antibiotic resistant. Normal E. coli exhibited a low resistance to most antibiotics. Resistance was seen to be high in 3-GCR and quinolone-resistant E. coli. Salmonella showed almost no resistance, except for one ceftriaxone-resistant isolate. Number 3, ESBL and MPC detection. Ceftriaxone was not susceptible against 40 E. coli isolates. Phenotypic test indicated a combination of ESBL and MPC producers. PCR and PC genes were found to be more prevalent than the ESB genes. Number 4, whole genome sequencing. A large number of isolates harbored the TET-A resistant gene of tetracycline. WGS was primarily in agreement with the lab antibiotic resistant. Quinolone resistance was associated with mutations of GYRE or QNR genes. For discussion, first one is the disk diffusion protocol had good performance and would be appropriate in low cost and resource limited laboratories, yet it also provides good results. Second, the bacteria that were cultivated in the presence of no antibiotics were largely susceptible, whereas the bacteria cultivated in the presence of antibiotics displayed multi-drug resistance, which was probably because the resistant genes were co-located on plasmids. 3. MPC producing E. coli outnumber E. coli ESBL producers. and some ESBL is due to phenotypic testing was false positive, and PCR served to clarify the situation. For whole genome sequencing largely corresponded to the phenotypic findings and validated major resistant genes and mutations, and particularly quinolone resistant. For the conclusion, this study revealed that E. coli and Salmonella that were resistant to antibiotics were present in the dairy farm, although their quantities were usually low. The selective media was used to better identify the few resistant bacteria. The low-cost protocol that was tested in this study was evident to be reliable and applicable in laboratories with limited resources. Lastly, the findings were supported by PCR and whole genome sequencings, which proved that the methods of resistance detection were accurate. That's all from me. Thank you.